messing up on me. What's up with that? Anyway, we are back live. Well, YouTube isn't messing up with me in the way of not live streaming. YouTube is messing up with me in the sense of not loading the live chat when I want it to. Although I do believe it is still live, which it is. Which I'm loading it up on my phone right now, just to confirm that stuff. Come on. Oh, the internet. There it is. Good. Okay. All right. We are back, man. I feel like it's been forever, but like I had you guys on Friday of last week. Oh my gosh, that is nuts. Couple of reminders moving forward. Number one, obviously we know about the schedule change for next week. The schedule change for next week, where they're going to be going full day. Yay! Oh, happy day! Yay! Have they told you guys what those like extra 23 minutes are supposed to be? Not really. Yeah, they keep. What I was just doing before when I was on, I was literally searching through my email and the school website for any like bell schedule, for any like details. I feel like I've deleted it just for the fun of it. I don't know. But like, I don't know. It just seems very hazy right now because especially since I'm going on like the school website, I'm not seeing like a full bell schedule. But yeah, we're going to be in this classroom for the full 84 minutes. We'll be able to develop some more ideas for some of the concepts that we're going to be learning in future chapters a little bit more in detail. It's going to be nice. Time is going to fly by. I guarantee you May is going to feel like it's going to fly by because we're already like almost at the end of April. It just constantly blows my mind. I haven't actually updated this, but like check this out. My calendar right here. Boom, 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 boom. That's where we are at the 21st. We're literally almost at the end of April. April has flown by so fast that I haven't even filled in May yet. My goodness gracious. Anyway, for those of you in the live chat, if you would leave a comment, that would be fantastic. Even though it's not loading on my laptop, I do have that thing loading right there on my phone, so you can see that right there. Just showing the people in the live chat, that'd be fantastic. Okay. This morning at about 7:10, there was an assignment that was automatically posted to the Google Classroom. And for the first part of this class period, I want to explain what that assignment was so that you guys have, an understanding as to what is expected of you. I posted the project that I've been hyping for a couple of class periods, and I wanted to bring that up on the board right here. I wanted to explain what is expected of you and talk about the due date and all that fun stuff in between. So that's the first thing that I want to do. Afterwards, I want to get back into cheapest link. I have a few things to talk about with cheapest link, including why that last problem we did on Friday didn't work. I now understand. Well, I understood that day, but I understood why that problem was not working. Well, let's bring this thing over so I can explain to you this project situation. Boom, boom, Hamilton project. Instructions. Okay. So this won't be due until I made it due Thursday the 29th. Because next week, wait, I have you today. Today's Wednesday? Yeah. This calendar is correct. Yeah. I have you Wednesday, I have you Friday, and then I have you Tuesday and Thursday. Yay, we did it. It's going to be due Thursday of next week. And what this says is attached is the information for the Hamilton project. The directions are in the PDF. I'm going to go over the directions with you. There is also attached a blank mileage sheet, which, again, there are actually two versions of it. There's a PDF and a Google sheet, depending on which one you prefer. There is also a printable map of the United States that is blank, which technically should be used twice in this project, so make a copy. And then it gives you some additional instructions. But let me open this up in Lumen PDF so you can see what is expected of you for this particular project. Opening, make it large. And there we go. Cool. Here's what you're going to do. You are going to select 3 locations in what they call the contiguous United States. The contiguous United States are the lower 48 states. I would prefer that you not pick anything in Alaska or Hawaii, so we are sticking to the lower 48 states. There are a couple of restrictions here. Of these 3 locations in the lower 48 United States, you are not allowed to use state capitals. So please make sure that you're not selecting a state capital. And you are not allowed to select other locations within states of provided locations. I'll explain what that means in a little bit. I have provided other locations. For example, Barnegat. Barnegat is the beginning location, of course. But since Barnegat is already a location within this project, you are not allowed to select a city within New Jersey. I believe I've also selected New York cities, which means you're not allowed to select anything within New York. I've also selected Los Angeles, not anything in California, et cetera, et cetera. You'll see when we get there. Your 3 locations that you pick must be approved by me. Either speak to me directly or send me an email, and the shared Google Sheet will be updated. I'll show you what that looks like in a minute. But here's the key. You cannot pick a location already on the Google Sheet. So I'll use Trenton as an example because you can't choose it. But if you were, someone would email me their 3 locations. And then one of them, let's say we're Trenton, New Jersey. And then what I would do is I would go to, where is it? There it is. I would go to this Google Sheet, and I am allowed to edit it, but you guys are allowed to view it. And I would update that city and state. So again, not allowed to use Trenton, New Jersey, but I would type it in like this. I would make sure they're organized alphabetically. And then no one is allowed to use that city and state, or that city, I should say. So I'll make up a different one. I'll use, no, I can't use that one. Yeah, let's use Carson City. So Carson City, Nevada. Now that's the capital, not allowed to use it. But if somebody chooses Carson City, Nevada, that's, okay, I'll update the list. And if somebody else uses Las Vegas, Nevada, that is okay. That is fine. Just you're not allowed to use the same city as someone else. You'll see when we kind of get moving with this thing. Let me go back to this. There it is. Cool. So once I update that, you'll see that Barnegat, New Jersey must be used as your starting and stopping point. The cities already on the mileage sheet must be used by everybody. Now, again, I go back to the project. What do I mean by that? Here's the mileage sheet. Now, the mileage sheet, I'll open this up in a PDF form as well. Come on. I thought I already went through that clicky thing. Silly thing, you. And I'll update this as well. There we go. So on this mileage sheet, and we're going to get a little more practice with this thing today. I have a couple examples that we're going to do. But on this mileage sheet, you're going to see that there are cities that are already pre-selected for you. Barnegat obviously is one. New York City, Los Angeles, Chicago, Houston, Charlotte, North Carolina, and Jacksonville, Florida are the cities that you have to use on this particular project. But that means that you are not allowed to pick a city in California, New York, Illinois, Texas, North Carolina, or Florida. You have to pick 3 cities in other states. Now, once you have all these cities, you can begin potentially filling out this particular grid. Now, like I said, I gave you a PDF version, but I also gave you a copy of a Google Sheet version. The Google Sheet version, you could literally edit the page itself. I don't know, 1, 2, 3, 4. I don't know what number that is, but I'm just going to type in the number 1, 2, 3, 4. You'll see how we're going to fill that out later. Back to, where is it? Here it is. Cool. You're going to fill out the provided mileage chart according to maps.google.com, only driving. And I'll do a couple with you just to kind of show you what you can do. I showed you a little bit last week, but I just want to reaffirm that. Then, after you have filled out the mileage chart, you are to determine the Hamilton circuit using the nearest neighbor method. Now, I thought I had updated that to say repetitive nearest neighbor. Yeah, but I'll leave it as is. That's okay. Then you are to explain the procedure you use to find the answer. Number 3, then you are to determine the Hamilton circuit using cheapest link, which we're going to get more practice with the cheapest link today. How many total miles will be traveled? Explain the procedure, blah, blah, blah. Then you are to fill out the United States map, marking all locations on the mileage sheet and the connected circuit that you found for each method. I'll show you an example in a moment. Then there's reflection questions, and then what I expect for the final product. And then there's a scoring rubric down there for you. Cool. Let me open the printable map, and I'll show you what I'm referring to. You're going to use that mileage chart to find nearest neighbor, and you're going to find cheapest link. And then you are going to fill out 2 of these maps right here. Now, you could fill them out directly on the computer if you wanted to, if you have like the skills of doing such a thing. But you don't have to. You could print it out and literally draw this thing out if you wanted to. Where's my red marker? There. No, it's not the real red marker. Oh, it's in my pocket. There we go. So you would mark things out like this. Here is Barnegat, and maybe I'd label it as Barnegat. Here is Jacksonville, Charlotte, North Carolina, Chicago, Illinois, Los Angeles, I think, is down here. New York City is over here. I ran out of space. Houston is down here. 1, 2, 3, 4, 5, 6, 7. Those are the 7 cities that I require that you do. But then whatever other cities that you choose, you are going to obviously fill them in on the map. But then you are going to show the actual Hamilton circuit that you found, let's say nearest neighbor. So for example, with these cities right here, I don't know what other 3 cities you would choose, but with these 3 cities, you have to start in Barnegat, and then nearest neighbor, maybe you'd make the connection there and then record the mileage. And then the next nearest neighbor would be like down here or some junk, and then nearest neighbor here. And then I don't know how close Houston or Chicago is, but let's just say nearest neighbor would be up there, and then nearest neighbor would be down there, and then nearest neighbor would be out here. But then you would have to return home. You have to return home to Barnegat. So, boom. And that would be the path that we would potentially take. Now, again, I'm not accounting for the 3 other cities that you are going to choose. So obviously your map is going to look a bit different. But this is just one potential way that it could look. You are going to justify that circuit using that mileage map, which again, we'll get more practice with today. So what is expected of you? What do you currently have to do? What you have to do, either, before the end of the day, before the end of the week, I don't know. You just have to pick 3 cities according to my rules. No state capitals. You can't pick anything within the state that has already been chosen. You are to email me the names of those 3 cities. Then I will update the Google Sheet for the cities so that no one else can use those cities. Once you have that, you can fill out the Google Sheet with whatever city you chose. There's city A, city B, city C. Those are the cities that you chose. And then we can begin filling out this chart. Once you have filled out this chart, then you got to find nearest neighbor and cheapest link. It's kind of, it's not as bad as it seems. It seems like it's got a million steps to it. But in reality, it doesn't. Once you get into it, things kind of tend to flow with it. To give you just a reminder as to how to use Google Maps with this thing, maps.google.com. If you go to maps.google.com and you type in Barnegat, New Jersey, where's the thing for the directions? Oh, I missed it. There it is. Directions. There we go. I needed to click directions. Barnegat, New Jersey to New York City. Boom. Just type in something generic like that. And I don't care about how long it takes me. I don't care about how long it takes me. What I care about is the mileage. So if you look at the left side right here, I know it's a little difficult to see from the live stream and whatnot, but if you look right here, it says 88.4 miles. If I click that, you can see that right there, 88.4 miles. It's a little bit easier to see. So then when I go back here, I would literally type in 88.4 and 88.4, and that would be the connection between Barnegat and New York City. I'll do one more. I'll do New York to LA, let's say. Or no, I'll do Barnegat to LA. So Barnegat to LA. If I wanted to do Los Angeles, California, take a moment to load with the internet. Again, I don't care about the time it takes. I care about the distance. And the distance is 2,770 miles. So I would go to my blank sheet right here. And I can type that in. Now, obviously, if you print this out, you can write in those numbers. That's perfectly fine. But that's how you would fill out these charts. You would have to find the mileage distance between each city and fill out the chart accordingly. Doesn't take that long to do, but that's why I made this project due Thursday of next week, because you could take this in steps. Number one, pick 3 cities, email me, get them approved. Okay. Then the next day you go back and you fill out this chart. Okay. And then the next day you go back and you find out nearest neighbor. The next day you go back, you find out cheapest link. It doesn't take that long if you kind of break it up into all of those steps. But you're going to have the opportunity to fill out this chart. Of course, like I said, you need to fill it out with the 3 additional cities that you picked. I'll show you an example of the types of cities that people have chosen. Because in reality, you can pick whatever city you want, just as long as it's not within a state that's already been selected. There it is. Here's the city list from 2019. This is from a different class that I had. But you can see some of the places that they picked. Like somebody picked Dinosaur, Colorado. I don't know. Somebody picked a place called Monkey's Eyebrow, Kentucky. I don't know. There's a bunch of weird names out there. There's a town called Dinkytown, Minnesota. Like, I don't know. I had accidentally approved a state capital. That's why there's a note there. I accidentally approved a state capital, but since I approved it by accident, I let it slide. You know, but you got to know your state capitals. Boring, Oregon. I thought that was funny. And then, of course, you can just pick, like, Fart, Virginia. There's a place called Fart, Virginia. I don't know if you knew that. I don't know. I found it funny. But you can pick, like, famous places. Like somebody picked Myrtle Beach, South Carolina. Somebody picked the Poconos, Scranton, stuff like that. But you can pick whatever you want. You just got to email me, get it approved, and then you can begin filling out these charts. So like I said, the final product. What I'm going to expect for the final product. I want the filled out mileage chart. You can either fill that out by hand or you can fill it out on the computer because I gave you a copy of a Google Sheet version. I want the total mileage traveled by nearest neighbor and cheapest link. Obviously, I'm going to double check to make sure that they're correct. I want 2 maps of the United States. One of them filled out for nearest neighbor and one of them filled out for cheapest link. Because the thought process is that if you do one method over the other, you're going to get different routes. And then I want the typed answers to the reflection questions. Those are the things that are necessary in the final product. And then, of course, the rubric is how that thing will be graded. So, yay. Again, this will be due Thursday of next week. And like this, the PDF version. Again, you could fill this all in by hand. But if you fill it in all by hand, like you print it out, you could either scan it or take a picture of it to make sure it's a clear picture that I can make things out in, and you can send that stuff in a Google Doc or in a Google Slide. I couldn't think of the phrase Google Slide. Yeah. Remember, it has to be the lower 48 states. You can't pick Alaska or Hawaii. I don't want Alaska or Hawaii on here. I mean, you could technically drive to Alaska, but you can't drive to Hawaii. That's just weird. Don't do that. Close that out there. Cool. Okay. I want to try a little practice with cheapest link. If you do have any questions in regards to the project, please make sure that you are messaging me. But I want to try a little practice with cheapest link right here. I figured out what went wrong with my problem from last week. Last week, we did a problem where I ended up hitting like a roadblock, and I'm like, what the heck do I do with this one? And what I found out was that the reason why it couldn't continue was because there wasn't a connection between every set of vertices. There was not a connection between every set of vertices. This problem right here, if it'll focus, and I'm going to send this to you in the chat in a moment. This image right here for the first exercise, there is a connection between every set of vertices. You could even see that down here. There is a connection between every set of vertices. On the back, again, this one's a little bit crazier, but you can see the connection between every set of vertices. And then, like I said, we are going to get practice with this mileage chart. I'm going to show you what we can do with this thing, but you're going to get practice. We're actually going to do this problem together where we're going to do cheapest route in order to get this thing done, or cheapest link. Why do I say route? Anyway, so let me freeze this for a moment. Freeze. Here we go. I am going to send to those of you in the chat a copy of this worksheet. Come on, there it is. There it is. PDF for today. Unfreeze. Post. Boom. There we go. Yes. So for those of you in the chat, I just sent you this worksheet so that you can have a copy of it. It is now in your Google Classroom stream. Fantastic. Let's try to get some practice with cheapest link. There we go. I found a colored pencil. The way cheapest link typically works is that you find literally the cheapest connection, the absolute cheapest connection. But there are certain rules that you have to live by. You are not allowed to close out the circuit before you have hit every vertice. Also, for every vertice, there is going to be a point at which you enter and a point at which you leave. Meaning there should only be, in the end, 2 edges connected to every vertice. This right here is the cheapest link on the entire thing. So I am definitely going to have that as a link on my circuit. The next one, 1.4. I am definitely going to have 1.4 as a connection on my circuit. But now, again, here's the little bit of the issue. The next cheapest link would literally be 2.1. But I can't do that. I cannot, and I'll erase this in a moment because this is dry erase marker. I can't make this connection because there would be 3 edges coming out of D. I can't do that if I'm making a circuit. If I'm going to make a circuit, then you're going to enter D at some point, and then you are going to leave D at some point. But then you're not coming back to D. You visit every vertex exactly once. So I can't do that connection. I'm not allowed to. If it helps, I can do something like this, because I am not allowed to make that connection. The next cheapest connection is 2.2. It's perfectly acceptable for me to do this. It's not ruining any circuit on the board. The next cheapest is 2.3. Yes, 2.3. And this is fine because it doesn't ruin my circuit. The next cheapest connection is 2.4. I can't do that because that would ruin A. A would have 3 edges coming out of it. I can't do 2.4. The next would be 2.6, but I can't do that either because that would ruin C and actually close off this weird loop right here. I mean, clearly you can hopefully see where the loop is supposed to be closed. And there it is at 2.8. 2.8 would be where it would close. That is cheapest link for this particular problem. Now, I don't really care about the questions that they have right there. The questions on the PDF itself, it says, how many steps will there be in this problem? Don't worry about that. But I do care about what is the circuit. And the circuit for this one would be A. I mean, does it say where to start? Doesn't say where to start. I'm just going to start at A. A, B, E, D, C, A. There is my cheapest link. I'm going to add up all this stuff. Let's see, 2.2, 2.8, 1.2, 1.4, 2.3. It says, what is the total weight of the circuit? I got 9.9. That's literally what we could go through for this cheapest link algorithm. Now, of course, I taught you this a little bit last week. I wanted to spend a little bit more time practicing it. I found that exercise 2 is not that nice. Exercise 2 has a decision to make at some point, and I'm not a huge fan of it. So what I'm going to say is this. Take a little bit of time right now, not with exercise 2, but with exercise 3. It says a space expedition is scheduled to depart Earth to visit the moons, Callisto, Ganymede, Io, Minas, Titan, whatever, to collect rock samples and return to Earth. The graph to the right shows the travel time in years. Cool. Don't worry about how many steps will be taken. What I want you to do, and I'm going to freeze my screen, and I'm going to try this as well. I'm going to freeze my screen in this, but I want you to try exercise 3. See if you can find the Hamilton circuit using cheapest link. So I'm going to freeze my screen, and I'm going to try this myself, and we'll see if what you get matches what I get. Let's take a look here. Close that out. Do that. There we go. I can do that one. Just remember, as long as it doesn't ruin the circuit, As long as it doesn't close off that loop, as long as there's not 3 edges coming out of a vertex, things should work out exactly the way that we want them to. Mm-hmm. Can't do that one. Lasted. That's where that one was. I can't do that one. I have to do that one. These do take a little bit of time sometimes. Which is why it is always good to do these in pencil. Of course, I'm doing this in colored pencil. This may not be the best idea, but we'll see how it flies. So looks like I did that one. Can I do that one? I can do that one. And I don't think I have a choice. I think I have to do that one. Yep. Boom. I had made a huge mistake on my first attempt. I'm glad I made extra copies, but now I don't have that many copies left. Here's what I got. Doo-doo. Here's my messed up circuit right here. We have to start at Earth. We'll start at Earth, and the direction doesn't matter because I made the circuit complete. So let's just say I did ET MGICE to make that connection. Of course, I could go backwards. I can go ECIGMTE. What I did initially was I messed up where that 1.1 was. That 1.1 on my first attempt, I had thought that 1.1 was right here, but I had screwed up because that's actually 5.2. And I found out that after I did the 0.6 and I did the 0.8, which are definitely necessary for cheapest link, the 1.1 is actually right here. And that influences everything else, because then once you do that 1.1, you're not allowed to do that 1.5 because that would close off that triangular loop. And you can't do that. You got to make a complete circuit going through every vertex exactly once. And then from there, it was just a matter of, okay, well, if I can't do that 1.5. And then once this I was closed off, I can't do that I anymore. So I was able to close off stuff going into that I. I was able to close off the 3.6 and the 5.1. Visually, it's a little bit difficult with where the numbers are supposed to be. But that's what I got. And then, like I said, as always, they want to know how many years will this expedition take. 8.1, 0.6, 5.7, 1.1, 0.8, 3.1. Boom, 19.4 years. You guys ever see, what's that movie that came out a couple years ago with, goodness gracious, Matthew McConaughey? About space? Nothing? It's like they had a little bit of like a time travel thing in it. Okay, cool. Goodness. What is this? Okay. I can't remember the name of it now, but I think what it had to do was that they were trying to save the Earth, and they had to like travel to these like different locations in order to determine whether or not like, okay, we can't save the Earth, but we can get all the people off it. We got to find a new place to live. But in order to do so, it took like a very long time. And ultimately, like he got stuck in like a black hole. It was a weird movie. I don't know. I think it was Christopher Nolan. Whatever. Christopher Nolan. Flip it. Going to the back. Now, I don't want to do this one right now. But what I do want to do is, and this is going to help and better inform your project, I want to do this table right here. This is going to better inform your project and help you, once you have that table filled out, solve the cheapest link and nearest neighbor portion of that project. It says a country western band based in Nashville is planning a 7 cities tour. The mileage chart for the 7 cities is given in the table below. So you have to start in Nashville and ultimately end up back in Nashville. They want a complete circuit. But if you're doing cheapest link or nearest neighbor, that's going to inform how you go about filling out this chart. So what I want to do, I want to fill this out using nearest neighbor first. And then if I have time, I'll see about, I'm sorry, cheapest link. I want to do cheapest link first because that's the one we're practicing today. And if we have time, I'll go back and do nearest neighbor with the other one. So I'm definitely going to do cheapest link with this one. Now, cheapest link with this table, once you have this table filled out, is actually quite nice. Remember that this table is a mirror image. It's a mirror image along the diagonal. Every single mileage on the top is repeated on the bottom. I mean, if it helps, you can do something like this, but it's like, okay, I got to find the cheapest link. Let me find the cheapest connection that I possibly can on this chart. Here is that cheapest connection. And I'm only really focusing on the bottom left half. There is the cheapest connection. It is, I'm going to make sure, the camera can see it. Nashville to Louisville. That is the cheapest connection that I can make. Okay. What is the next cheapest connection that I can make? I want to say it's 243. I think it's 243. Again, I'm just focusing on the one half. 243. And that connection is between Houston and Dallas. Houston and Dallas. Okay. So far, I haven't blocked anything off yet, but you'll see what happens. I believe the next cheapest connection's got to be 263. Yeah, it's 263. Again, just focusing on this bottom left portion. But that 263 connection is between St. Louis and Louisville. Now, here's awesomeness, right? Check this out. St. Louis. Louisville is blocked off. Louisville is blocked off. There's no other connection that's going to be made to Louisville. Louisville's done. So Louisville to Boston is not going to happen. Louisville to Dallas, Louisville to Houston, none of those are going to happen. Those are eliminated. You could also eliminate Louisville to Pittsburgh right here. All of those are completely eliminated because Louisville is blocked off on this little sketchwork up here. So I'm going to go for the next lowest one. The next cheapest one that I can find is Pittsburgh to Nashville. Pittsburgh to Nashville. All right, so this is getting a little weird up here, but let's go Pittsburgh to Nashville. But now Nashville is blocked off. Nashville is between Pittsburgh and Louisville. So since it's blocked off, then I'm going to say, okay, I can't do this one. Can't do Nashville to Dallas. or to Houston, and I can't do Nashville. Oh, yeah, I can't do Nashville to St. Louis. I can't do any of those. Basically, as you're filling out the chart, it becomes a bit nicer because there's a lot of stuff that's been eliminated that I am not allowed to do. And you can tell based on if they are blocked off within this little sketchwork over here. The next cheapest one, Pittsburgh to Boston. So, Pittsburgh to Boston. Pittsburgh's blocked off. So this one's gone. And this one down here is gone. Don't have that many left to choose from. Let's see, Dallas to St. Louis. Yep, I can make that connection. Boom, Dallas to St. Louis. But again, St. Louis is now blocked off. St. Louis is now blocked off completely. Dallas is now blocked off completely. And I only have one connection left. Only one connection left on this entire chart. And it is Boston to Houston. There is my loop. There is my loop through all 7 cities. Now, once I have this loop, it's like, oh, okay, well, there's 2 things I have to do. Name the loop, or like, what is the route that the band will take on this tour? Well, you have to start in Nashville. So I'll do Nashville to Louisville to St. Louis to Dallas to Houston to Boston to Pittsburgh, back to Nashville, because I have to end up back in Nashville. And then ultimately, oh, well, you know, how many miles did you travel? Literally, if you filled out the chart correctly, just add up the ones that you ended up circling, and that should work out perfectly. Well, actually, it's a little bit more complicated than that. Let me do it like this. Because some of these numbers, because I got 7 cities and I only circled 7 numbers here. So let me see how this actually works out. So Nashville, where's Nashville? There it is, Nashville to Louisville. Where is it? There it is. It's 168. I don't know why I couldn't see that. I'll just fill them out one at a time then. Houston to Dallas is 243. Houston to Dallas is 243. St. Louis to Louisville is 263. And then Nashville to Pittsburgh. Nashville to Pittsburgh was 394. There it is. And then, so I got the 168, I got the 263, I got the 243. The 630 St. Louis to Dallas was 630. Houston to Boston was 1804. That was a big one. Boston to Pittsburgh was 561. Yeah, I did get all those numbers right then. Cool. Yeah, 1, 2, 3, 4, 5, 6, 7. Back to Nashville. Cool. I just add all those up and we're good. Whatever that mileage is, that'd be fantastic. I like this thing for cheapest link. But that's how we would go about it. Like I said, once you fill out your little chart for the project, it would be helpful to potentially print that thing out. Because if you print that thing out for that project, let me go back here real quick. Let's see, there we go. If you printed this thing out, this mileage sheet, with all 10 total cities, the 7 that I give you and the 3 that you pick, then it may be easy to do this thing by hand, by like crossing things out, just print it out a couple of times, and that's the work that you would do in order to get this thing done. Be fantastic. So let me flip back to here real quick. I know they asked this additional question about gas mileage. I'm not worried about that right now. Let me think here. I want to compare these two, but I want to do, I'm going to write this down and then compare it to what we get for nearest neighbor. Dallas, Houston, Boston, Pittsburgh, back to Nashville. I just wanted to compare that against what we do for nearest neighbor. Now I want to do nearest neighbor. Nearest neighbor. I would not ask you to do brute force. Doing brute force on a project like this is absolutely ridiculous. I don't know who in their right mind would ever do brute force on this project. Don't. But if I'm doing nearest neighbor, then you could do this in a number of different ways. You got to start in Nashville. You got to start in Nashville. Now, this one, you might want to use the entire length of the chart. That's up to you. But let's figure this out. First of all, from Nashville, Louisville is the closest connection. From Nashville, I have to go to Louisville next. From Louisville, if I'm looking across the entire chart, I can't do Nashville, but the closest connection would be St. Louis. From St. Louis, I can't do Louisville and Nashville. The closest connection for St. Louis then would be Dallas. From Dallas, I can't do, bless you, Louisville, Nashville, St. Louis. I can't do those three. But then the closest connection to Dallas would be Houston. From Houston, I can't do Dallas. I can't do Louisville, Nashville, or St. Louis. The closest connection would be Pittsburgh. And then from Pittsburgh, I think I have to go to Boston. Yeah, I have to go to Boston after Pittsburgh. And then from Boston, I have to go back to Nashville because I have to end up back where I started. I have to end up back where I started. Nashville. Let me figure out what those distances were. But that's literally how you could go about nearest neighbor. So, what's the route they will take? They'll go Nashville to Louisville to St. Louis to Dallas to Houston to Pittsburgh to Boston back to Nashville. I just want to add all these up real quick. I want to compare the two. 1204, 263, 168, 561, 630. I think I got all the 4157. The total distance they'll travel is 4,157 miles if they found this route using nearest neighbor. If they found this route using nearest neighbor. Now, I didn't write on the cheapest link. I'm going to flip over to the cheapest link in a moment, but I want to compare the two. I should erase those. I'm not going to have to redo cheapest link since I wrote it down. There we go. Let's see here. There we go. I wrote it down right there. So Nashville to Louisville. I'll just do that. Louisville to St. Louis. St. Louis to Dallas. Dallas to Houston. Houston to Boston. Yeah, ultimately is what we found out. And then Boston to Pittsburgh. And then Pittsburgh to Nashville. There we go. Let me add all those up and see what we got for cheapest link. 1804, 561, 243, 630, 168, 263, 394. Get 4,063 miles. So, cheapest link, 4,063 miles. Nearest neighbor, 4,157 miles. Ended up changing the route, which is fine, because that's what the methods produced. But this is what you are going to investigate in your project. This is what you're absolutely going to investigate in your project. There's no guarantee which one will produce the shorter route. There's no guarantee of that whatsoever. It's just you got to try it and see what happens. Some of you will end up having nearest neighbor being the cheaper route, or being the shorter route, I should say. And some of you will have cheapest link being the shorter route. It really depends on a lot of different factors. Like I said, I'm not going to have you do brute force. That would be ridiculous. Who in their right mind would do brute force on this one? That would take forever. Have a computer do it for you. But yeah, this is what I'd like you guys to try and do. It's going to be fantastic. I mean, for me, mainly for me, because I really like the maps of this project. When I was a kid, I had a fold-out map of the United States, and I would lay it out. I was like 7 or 8 years old, and I'd lay it out on my floor. And depending on like the cities that I had visited or been to before, I would kind of like try to mark them off. Or if there was a major event going on in the United States, I would try to determine where I was in comparison to where this major event was. It's kind of fun. I enjoyed geography. I don't know. They don't teach geography anymore, do they? For geography? Oh, no. I know what you're saying. Human geography. That's actually a bit different. Human geography and geography are close, but they're not exactly the same. Human geography is like the study of like people patterns through visual maps and things of that nature. Like one of the things that I learned was like a map of the United States and like what's the most common phrase for soda, for example. You know, like in certain parts of the country they just call it Coke. In certain parts of the country they call it pop. You know, what do you call it? Yeah, you ever met someone who calls it pop? Yeah, isn't it weird? You just want to punch them. Never mind. Don't. Yeah, but it's like human geography. That's just one silly example, but it's like, you know, like humans and how they develop, you know, habits and social cues and things of that nature, and just over the course of time, the development of human beings, human geography. It's kind of, you know, it's kind of interesting. But anywho, like I said, yeah, this project will be due on Thursday of next week. I'll give you, obviously, on Friday, a little bit of an opportunity to get some of this stuff done so that you don't have to spend forever doing this on home. But you'll have an opportunity on Friday to do a little bit of this in class at the very least. Scratch work, if not, you know, moving forward with it. But your job is to email me or contact me. It says to, in the project itself, it says to either email me or speak to me directly about what 3 cities you would like to choose. Again, they can't be state capitals and they can't be a city within a state that's already been used. I'm sorry, let me rephrase. In a state that's already been used on this form. So you can't use Florida, North Carolina, Texas, Illinois, California, New York, or New Jersey. You can't use those states. Every other state is fair game, except Alaska and Hawaii, because you can't drive there. You know what's silly about roads in Hawaii? There are officially designated interstate roads in Hawaii. Think about that. Interstate roads. Weird. I have seen a Hawaii license plate, though. Have you? Yeah. They have them, you know, just ship them over and stuff like that. But anyway, so Class should be over in about 3 minutes. I ended a little sooner than I wanted to. If you guys here, if you think of cities that you would like to do that I can add to that list before we leave here today, of course, you can tell me. For those of you in the chat, obviously, you can email me if you can think of the 3 cities that you would like to do. If one of the cities has already been taken, of course, I will let you know of it. Make sure you're checking the Google Sheet for Hamilton Project Cities 2021 before you contact me about your 3 cities. That'd be fantastic. Anyway, I'm going to sign off in the chat. If you haven't already commented, please make sure that you do so. I do see the comments that you guys have left so far. Oh, yeah, she's there. But I am going to sign off. Yeah, we'll leave it at that. Okay. Bye-bye. Click. Click. Boom.